So in this lesson, we will discuss the concept of distance formula, but before diving down into the concept of distance formula, we first have to see the concept of coordinates. So when I write x comma y, so this x is the x coordinate and this is my y coordinate, right? So, and I consider this whole thing as a complete point in the xy plane. Now, what do I mean by that? So basically, if I draw the x-axis and the y-axis, and for example, if I place a point over here, so this point is based upon two coordinates, which is x coordinate and a y coordinate. And this point is basically representing that from the origin, x shows the horizontal distance, and from the origin, y shows the vertical distance, and this is the reason I have this point as x comma y. Now, for example, I have another point like here. So this will also be x comma y. But just to differ it from the first point, what I can do is I can just take this as x1 and y1 and take this point as x2 and y2. And this is where the concept of distance comes into action, when we have to find the length between the 2 points. And this is where we actually use distance formula to find this distance d. So the concept behind distance formula is really simple, and it is given by a simple formula, which is y2 minus y1 whole squared plus x2 minus x1 whole squared. And as you can see that these x1, y1 and x2 and y2 are the coordinates that you have to just respectively place over here. Right, so let's take an example. Like for instance, I have to find the distance between 3 comma 1 and 4 comma 5. So what I can do is I can simply first of all label them as x1, y1 and x2 and y2. Now, what I can do is I can just apply the distance formula, which is given by the root of y2 minus y1 whole squared plus x2 minus x1 whole squared. Now you just have to respectively just substitute the values. So the value of y2 is 5. So I'll place 5 over here. The value of y1 is 1, so I'll place 1 over here. Similarly, the value of x2 is 4, so I'll place 4 over here. And the value of x1 is 3, so I'll simply place 3 over here. So how I can just do it now is really simple. So the value of y2 was 5 minus the value of y1 is 1 plus the value of x2 is 4 and the value of x1 is 3. Now all you need to do is just simplify this bit of information over here. So 5 minus 1 will give you a 4 whole squared plus 4 minus 3 whole squared is just 1 whole squared. So the value of 4 whole squared will give you a 16. 1 whole squared will give you just a 1. So 16 plus 1 will give you a 17. But don't forget to put it under the square root. So as I don't know what is the unit of the length right now, it may be centimeter, it can be meters, it can be kilometers. So as I'm not aware of the unit, so I'll just place units over here. So this is the length between the 2 points, which were 3 comma 1 and 4 comma 5. So we can do one more example. Like for instance, I have 2 points 0 comma now with a negative number maybe. So 0 comma negative 5 and 4 comma or maybe negative 4 comma -7. So first things first, that you have to first label the coordinates. So this is x1, y1, and this is x2 and y2. Secondly, you just have to write the formula, which is d is equal to square root of y2 minus y1 whole squared plus x2 minus x1 whole squared. So d will be equal to the root of, now you just have to place the respective values properly. So the value of y2 is -7. So I'll just place -7 over here. So -7, then I have a minus, and then the value of y1 is -5. But when I place a -5 over here, there is already a minus sign. So when I place a -5 over here, so minus minus will become a plus. And I'll place a whole square plus the value of x2 is -4 minus the value of x1 is 0, and don't forget to put the square. Now all you need to do is just simplify it a bit. So -7 plus 5 will give you a -2 whole squared plus -4, -0 will give you a -4 whole squared. And then the distance between the 2 points will be, so any base, any negative base having even power will always give you a positive result. So that means it will give you a 4. So -2 whole squared will give you a 4. It is same as 2 whole squared. A negative base having even power will always give you a positive result. Plus, a negative base having even power will always give you a positive result. So finally, the result will be root of 20 units. Now let's consider one more example, but this example is quite different from the previous ones because we have to find the value of m in this question. This m can be any unknown, any letter from A to Z. The only point of concern is that in this question, the distance is already given. Why? You can clearly see. Find the value of m if the distance between this point and this point is 6 units. That means the distance is already given. So you are only interested in the value of m. And I can see that this value of m is the x coordinate of this point right here. So first things first, that I label this as x1 and y1, and I label this as x2 and y2. And then, like we did in the previous examples, we just apply the distance formula. So distance d is equal to the root of y2 minus y1 whole squared plus x2 minus x1 whole squared. So I just need to see what exactly is the value of y2. I can see the value of y2 is 7. So let's start substituting the respective values. So the value of y2 is 7. So I'll just place 7 minus the value of y1 is 2, 2 whole squared plus the value of x2 is 10 and the value of x1 is m whole squared. And I can see that the distance d is 6 units. So instead of writing this d, what we can simply write is, we can simply write 6 over here. Now, just to make my calculations simpler, what I can do is I can just simplify this. So 6 is equal to the root of 7 minus 2 whole squared. 7 minus 2 is 5. 5 whole squared is 25. Now, there is a way to solve this question by expanding this bracket, but I don't recommend expanding this. There is a far more simple way to solve this. What we can do is we can take square on both sides because we want to get rid of this square root, right? So I simply take square on both sides, and this is square, and this root will be cancelled. So 6 square will give you a 36 is equal to 25 plus 10 minus m whole squared. And then you just take this 25 on the left hand side. So 36 minus 25 will be equal to 10 minus m whole squared. Now 36 minus 25 will give you 11 is equal to 10 minus m whole squared. Now I need to find the value of m. So all you need to do is just simple mathematical calculations right here. So what I can do is, as I need to find the value of m, so I need to get rid of this square. So when you have to get rid of a square, what you do is you take square root on both sides. So I take square root on both sides. So this square get cancelled out by this root. So I get root of 11 is equal to 10 minus m. And now I just need to find this value of m right here. So what I can do is I can just take this m on the left hand side and take this root of 11 on the right hand side. So finally the result will be 10 plus root of 11. Now if you want to give your answer in decimals, you can just solve it and give your answer in decimals. So this is my final required value of m. There is one more concept which is linked with the concept of distance formula. That is basically the distance formula can be written in a few forms, but all those forms are entirely the same. So the one I used in my examples was y2 minus y1 whole squared plus x2 minus x1 whole squared. But the thing is, this distance formula can be written down in the form in which you can write this bracket first and this bracket as in the second position. Now the reason behind this is this addition sign. Because when we add two numbers, like for instance, I'm adding 2 plus 3 will give you a 5, right? And 3 plus 2 will also give you a 5. And this property of addition is known as commutative law of addition. And this is the reason why I can basically interchange the positions. So this is the commutative law of addition. So addition does not change the result even if you just change the order of the addition, like you just change the positions. This comes at the second and this comes at the first. Likewise, there is one more thing in distance formula that you can even implement. That is, you can even change the positions inside the brackets. So what do I mean by that? So distance d is equal to the root of, you can even change the positions from here. x1 minus x2 whole squared plus y1 minus y2 whole squared. Even this thing is also entirely same. So all these three forms can be used to find the distance. They'll all give you the same result. Now the reason behind this is, why can I write x1 minus x2 whole squared plus y1 minus y2 whole squared, although here I'm using x2 minus x1 whole squared and y2 minus y1 whole squared. The reason behind this is the concept of this square. So this square will always make the result identical. Let me show you how. So 3 minus 5 whole squared and 5 minus 3 whole squared will give you identical results. So 3 minus 5 whole squared will give you negative 2 whole squared, and 5 minus 3 will give you 2 whole squared. But still, in the end, negative base having an even power will give you 4, and even here 2 square is 4. That means this bracket right here and this bracket right here makes the same identical sense.